Welcome to InventorCAM Professor. I'm Sydney, your InventorCAM Professor, and in this session we'll be talking about our modular of HSS, and we'll start off with the option of parallel cuts. In general, HSS is our modular that deals specifically with working on surfaces. All you do is basically pick the surface you want to work on and use the type of technology that you need for that particular surface. HSS also allows for undercuts and for gouge checking on the parts itself. Now we'll start off with HSS, and the first option I like to use in HSS is parallel cuts. Now as you see, our window as it opens up, it follows the same format as the rest of any other machining process that we may have. So we'll start off with the coordinate system. In this particular case, all we have is 1. And then we'll go to our geometry. Now, in our geometry area, this is the spot where we can actually choose what type of technology we are going to be using. By choosing the type of technology, that will determine what kind of geometry we need also. If we look at our possibilities of patterns, we have parallel cuts, which I'll be demonstrating now. We also have perpendicular to curve, morph between two curves, parallel to curve, projected curve, morph between two surfaces, and parallel to surfaces. I'll start off with parallel cuts. Now, the next thing is, how do I want to work? Do I want to work parallel, or do I want to work constant Z? Constant Z is meant for working on the walls, where parallel is more for working on flatter surface. In this particular case, I want to machine this particular surface shown over here, so I'll choose the option of constant Z. Next thing I have to do is go to my drive surface, and over here I'll simply click on the surface that I want to work on and say finish. The next thing we have here is we can have a drive surface offset. That will allow for us to actually be offset from the particular surface that we are machining. Our next area is the area type. If I have to choose full avoid cuts at the exact edges, what will happen is that the tool will only go the center of the tool will not go to the actual edge of the part itself. Rather, it will move half the distance, the radius of the tool, away from those edges on both sides. We also have an option here called full start and end at exact surface edges. That will actually have the tool go to the exact edge of the part. One more option we also have is we can also limit cuts by 1 or 2 points. By simply picking a point on the surface itself, I can limit it to work between those 2 points only. In this particular case, I want to use the option of full start and end at exact surfaces. The next, I must pick a tool, and the tool I will be using will be a bullnose tool of 10 millimeters with a 1 millimeter radius on the corner itself. Next, I'd like to go into levels. Now, in levels, we have the choice of having a going out clearance area up to the top plane, as shown here, or if we're working on a cylinder, actually have it going to a specific cylinder around the part if you were working on a machine with indexial fourth axis. In this particular case, I'm going to choose the option of plane, and we have the choice of retracting to a clearance area either in X, Y, or Z. In X, Y, or Z, for simple reasons, sometimes we're working on the side of the part and we're working with an undercut, and we first want to retract in the X or Y direction. In this particular case, I'm going to choose the option in Z direction, and over here we have the plane height as to where to retract to, what the plane height actually is. Now, in my toolpath parameters, we have our cutting tolerance, and then we have also our maximum step over. Another thing we have over here is we also have surface edge merge distance. If, for example, we had a specific distance between the surfaces, a break in the surface, if the surface break is less than this amount written over here, then it'll continue on to the next surface. If it's more, then it'll actually go back. We can control this either by value or a percentage of the tool itself. Now we also have a sorting option. We can work either zigzag, one way, or spiral. I'll choose the option right now of zigzag. And we have the option also of cutting order. We have the standard. We can also work from the center away. Notice, start from the center of the surface and work yourself away towards the edges, or from the outside to the center, as shown here. In this particular case, I'll use the standard cutting order. Now we also have an option of machining by, as far as the ordering goes. We can either do by lanes. By lanes it'll go 1, 2, as you can see over here. And it doesn't make a difference if you have a break over here. It'll go from one to the next area. Or we can do regions. Whereas in regions it'll first do the first area, then the second area over here, and then finish off the third area. Now let's go into our link area. And our link area shows us, first of all, how do we want to approach our first entity from the clearance area in this particular case. And if we want to use our lead ins and last exit when we leave the part, if we want to use our lead outs. In this particular case, I'm going to use my lead ins, and I'll also, in my last exit, use my leads outs. Now, as far as what type of lead in and lead out we'll have, we'll show that to you in a moment. But first, let's talk about gaps along. Now, if I have a small gap between the tool pass, such as if we look over here, we have these holes here, which is actually a gap as it's going to go along. So, if it's a smaller gap, and what's a smaller gap? If it's 110% smaller than the tool diameter, then you go directly to the next surface, pass it over directly. If it's bigger, then you actually would have the large gap. You would be actually going up to your clearance area until you get to the next spot. Now let's do a quick save and calculate just to see what we've gotten up until this point. And if we run our simulation right now, you'll see that the tool pass goes back and forth, and when it gets to these areas, these holes, it jumps up and only then and goes to the next surface and goes back down. Now what I'd like it to do is to actually not jump up. I'd rather it go straight across without jumping up. So for that, all I have to do is simply go into my links and change my gaps along from the large gaps also to direct. That way the tool will go directly to the next area. You can see in the simulation now that the tool pass will actually jump over these areas from one surface going directly to the next surface as shown here, without jumping up over the surface itself. Now, one other thing we should note is that we have also the issue of lead in and lead out. Now you'll notice because I chose the standard lead in and lead out, it came down and arced its way in. But if I wanted, I can actually have it coming down from the top and giving a vertical lead in. Sometimes this is necessary because I can't come in from this side because it may have material from over there. This is controlled by the default lead in and out. As you can see right now, I chose the option of tangential arc, and that is actually the default option. If I were to choose the option instead of vertical tangent arc, then the tool will come in from vertical from the top, and then only then arc its way in. If I'll do save and calculate, and then I'll show you the simulation what we have right now, you'll note that the tool will come down from the top as shown here, and then arc its way across through the entire part. And when it gets to the end, the same thing is done. Now, obviously, if I want, I can have my lead in parameters this way. But if I go to my lead outs, right now it's marked as the same as lead in. But if I want, I can have a different type, and I can simply say over here, I want tangential arc. Now when I do save and calculate, and my simulation, you'll note that the lead in is vertical from the top, but my lead out works in a tangent in a standard way as it did before. Now we also have control as far as how big of an arc do we want. We can have it actually go in from a complete 90-degree angle or change that if we want. And as far as the arc diameter itself, we can actually have it at a percentage of the tool. Right now it's 200% of the tool. So if I have, for example, a 10 millimeter diameter tool, and I have this at 200%, the arc that it will go in at will be a 20 millimeter arc. We can also decide to use width and length instead, where I can say I can want my width from the part as shown over here at 20, but my length only at 10. Now if I were to do save and calculate, and let me just change this back to same as lead in, you'll note that there is a change in the shape of my lead in. You'll note that it came from 20 millimeters out. However, we have a shorter arc from the bottom in, as shown over here. Now, there are other options here such as gouge check and roughing, but we'll get into that in a different session of ours when we talk again about HSS. Thank you for joining us on InventorCAM Professor. Take care and have a nice day.